Hello, and welcome to the first in the Design, Engineer, Build series of video podcasts from the Engineering Network. I'm Mark Sims, and in this series we're going to be discussing the key components at the heart of countless engineering systems. Today we're going to be talking about lead screws, and guiding us through the design considerations on these products is Phil Jones, Technical Sales Engineer at ABSSAC. Hi Phil, thanks for joining us.
Hi Mark, happy to be with you this afternoon.
Lead screws are products that are found everywhere in all sorts of applications. What's the enduring appeal of these products to design engineers?
Well, you're absolutely right, Mark. You do find them absolutely everywhere, and they are very competitively priced. They have good availability, and there are a wide range of materials available, and the lead screw threads can be manufactured or tailored to suit specific customer applications.
When we talk about lead screws, the three critical parameters that we always consider are load, speed and duty cycle. How are these three related?
Well, the three are intertwined quite closely. They're all important factors to consider, and you really can't leave any of them out when you're specifying a lead screw.
So what about load then? How does that impact on product selection?
Normally, the first case that we would talk about with the customer is how much load they've got to move. And essentially, there are three load cases for a lead screw. So we would talk to the customer, find out how the lead screw is arranged in their machine to get the values that we need. So really on the lead screw itself, we're thinking if it's being used as a column, so any column loading, or if it's in tension, what is going to be the tensile strength of the lead screw. The other loads we think about are, the actual load seen by the nut, and there are two load types there. There's the dynamic load, which is how much load the lead screw has to move, and the static load, which is a load that can be seen by the nut but not necessarily moved. So in some applications, you can have quite a low dynamic load, but a really high static load.
So let's think about speeds then. How does that impact on product selection?
Calculating the speed, you've got to work out or be careful that either you don't spin the screw too fast that it gets excited in its bearings and becomes unstable, or that the actual sliding speed between the screw and the nut is too fast, which causes overheating and then leads to wear.
So that brings us to duty cycle. Why is that such an important consideration in product selection?
Well, the duty cycle is essentially the time the lead screw is moving under load versus its time at rest. And so if the lead screw isn't left alone long enough to cool down, it can overheat, which then causes problems. How much that lead screw heats up depends to the load that it's moving and how fast it's moving. So the three are intertwined in that way.
If those are some of the key considerations, what other factors all have an impact on lead screw selection?
Well, each application is unique, and what we find is that customers have their own certain set of circumstances or operating conditions that we have to think about when specifying the lead screw. For instance, what's the environment like? Is it really hot, really cold? Is it at low pressure? The materials that we're using, do they need to be certified for any reasons? People in certain applications will only use, certified materials, and we're able to make the lead screws and the nuts from certified materials that have got full traceability back to source.
With those considerations in mind then, how important is it for design engineers to engage with a really knowledgeable supplier such as ABSSAC?
Because we deal with lead screws day in and day out, we know the information we need to extract the customer to offer them the best solution. We've got many years experience in specifying lead screws and can help the customer with all the questions they're going to have about use of the lead screw, the maintenance, how long it should last, and the other operating considerations that you would need to know as a design engineer in order to get the system to work correctly. Something like, how much torque is my motor going to need? We can help the customer with all these sort of questions.
Great. Thanks, Phil. Thanks for your insights. Good to talk to you. For more information on lead screws, visit absac.co.uk, and you can read my interview with Phil in the autumn issue of Industrial Technology. Thanks for watching. See you next time.